Hi guys, welcome to another episode of Code This, Not That. Hope you had a great weekend. Just to get you up and running, we are going to have a weekly challenge on data structure and algorithms. So, what exactly is data structure and algorithms? So, it exactly is about time complexity, space complexity. So, how does each function that we write affects the performance of our entire code? So, we are going to try to write a simple function that is going to take in an argument. For instance, it is going to be, if it is n instance, say if it's 2, we are going to return 2 plus 1, that is 3. So obviously you're going to ask, like, do I look like a kid? Am I supposed to do addition, subtraction? No, what I meant was, at this end of this lecture you might have a difference of opinion. So what we'll do is we'll try to write this function, and I'll just define a variable called total, and it is going to be incremented in this for loop. So for n numbers that is passed, we are just going to concatenate with the index so that it returns the total of numbers. So obviously that's a simple solution for you guys, but I'm pretty sure when it comes to performance, this is a bad solution. Even though it returns the correct output, I'm pretty sure we have a better solution than this. I think that output is somewhere like 55. Yes, exactly. That's because there is already a mathematical problem to it. In order to add n numbers, the formula is n into n times, sorry, it's n times n plus 1 divided by 2. So that's the formula. So we'll take in n as an argument. So if we implement this formula, we are going to have the same output. But what I'm trying to say is that it is much more better to the previous solution that we wrote. That's because this is what algorithm is all about. And also we'll try to see the performance, because it is not just a syntactic sugar. And even though it returns the same output, it doesn't function the same way because there is a lot more to it. So I'll just do a console time for calculating the performance, and I think you can visually see the performance difference here. Yeah, of course you might be first skeptic about, like, hey, it's just like, say for instance, twice the amount of performance, and it's just in milliseconds. I think it doesn't even matter for me. Yeah, obviously you are right, but what if I try to increment the n, so it has to loop through n times more? So obviously the performance is going to degrade over time, and already you can see that it's 1.4 milliseconds compared to zero point 0.3 milliseconds. So it's like roughly 4.5 times. Why don't I increase the numbers even more so that I can show you a substantial improvement? So just to show you that it's the same amount of n, I'll just do it, and you can see already we are making quite the difference. I'm pretty sure since it is in milliseconds, you won't agree with me. So just to show you that the complexity of the first solution increases over the n iterations because we are using a for loop. Trust me, it's running there, but you're not able to see it because it's taking a lot more time, because there is a lot more iterations going on in that for loop. So this is what we call it as time complexity, and the amount of time is exactly like log n, so that if that n increases, the time increases. We can see a substantial improvement in the second implementation. That's because it is exactly using a big O notation of 1. So that's what we call, it doesn't change over time, because the first solution has a lot of variables assigned to it and a lot of operations are going. That is what we call it as space complexity. So the first solution is not ideal when the input changes over time, but the second solution is far more better. So do let me know in comments, what do you think about it. This is Suren signing off.